Good day. In this video, I'm going to discuss what I have learned on Chapter 2, Stress and Strain Curve. In the previous video, I have already discussed about what I have learned on Chapter 1, Stresses, and now let's proceed to another video. Mechanics of Deformable Bodies, Chapter 2, Strain. We have 4 topics that I'm going to discuss, which is strain, types of strain, axial deformation, stress-strain diagram, and concept of stress-strain curve. Let us now proceed to strain. Strain is the measure of how much an object is stretched or deformed, where strain is equal to the changes in length divided by the initial length, wherein changes in length is simply referred to as total displacement. To sum it all, strain is equivalent to deformation of delta over the original length. Types of strains. There are 2 types of strains, normal strain and shear strain. Normal strain deformation that are applied perpendicular to the cross-section. It characterizes dimensional changes like changes in length or dimensions, while shear strain is the deformation applied parallel to the cross-section. It characterizes or describes distortions that are changed in angles here. Let us now go to the axial deformation. Since stress is equals to E multiplied by strain E, which is presented by epsilon, where stress is equals to P over A, while strain is equals to the delta or the permission over the original length. We have the formula here on finding deformation of material. Total deformation is equals to the applied load multiplied to length over cross-sectional area multiplied to modulus of elasticity. There are 3 conditions in using this formula. The bar must have uniform cross-sectional area, the load must be axial, and the stress must not exceed to the proportional limit. We also have formula if the cross-sectional is not uniform in determining the axial deformation by using integrals. Another formula in solving for the total elongation due to its own weight when unit mass P is suspended vertically from one end. Total deformation, this is the total deformation, total mass, gravity, length, and over 2 times cross-sectional area and the modulus of plasticity. Next is the stress-strain diagram. We can see in this diagram that the stress and strain is proportional to each other, as Robert Hooke said, but it only ends at the proportional limit. From the origin 0 to a point is called proportional limit, and it is shown as a straight line on the stress-strain diagram. In proportional limit, we are going to use Hooke's law. Elastic limit, stress beyond which material will not return to its original shape when unloaded, but after being loaded, the material returns to its original shape and dimension. Now, yield point. It is a point at which there is an appreciable elongation or yielding of material without any corresponding increases of load. Ultimate stress, highest ordinate on the stress-strain curve. It is commonly taken as the maximum stress of material. Rupture strength. As the failure occurs, the material stretches over rapidly and simultaneously narrows down. We also have allowable stress, maximum material safe stress a material may carry. It is also called working stress. We have the formula in solving for the allowable stress. Yield point or the ultimate strength divided by the suitable number, which is n, and that is called the factor of safety. Next, modulus of elasticity, the ratio of stress to strain, which is the slope of line. Modulus of elasticity is denoted by E.